No, we've done some stuff very similar. This is mostly easy. This is example 4. I haven't been naming the examples.
Which E stuff does it say?
Example E. No. There we go. So there's radius, there's the height above the planet, and then there's the radius. So satellite orbits a planet of radius. So that's the radius of the planet itself. So we're going to denote that with big R equals 7.5 times 10 to the 6 at a height of h meters. So that's above equals, who knows? At which, so the height above is the gravitation. So GS for G satellite and GS for G surface.
No, it's
Okay.
GH as in G height.
Yeah.
There's no G.
So we're finding little g's.
7.8.
6.6.
What we finding? We're finding the radius of orbit.
Not sure.
Oh, we're finding 8.
Above the surface.
Finding 8.
The acceleration
Oh, it's
Sure.
6.6.
due to gravity at the planet's surface is 7.8.
That is like the most swampy circle ever.
Out of my swamp.
GS.
Find h. Okay, we're finding h. So we have 2 radius terms, we have 2 g terms. What does this mean? It means we can use a nice. That's example 6. Well, example 4. Not fully done. No, it is done. Cool. So this means we can use the equivalence thing that I showed early on, which is GH. That's
Is
so
this the formula on the bottom?
R. R is the total height of everything. That's GHR equals GS surface. So R capitalized.
Remember to square it.
Hello. Square root, of course. And the square term is there. And then we just rearrange for find h. So didn't do that. Okay, yeah, we're using h, not r.
No, you still put R, and then you have to do R take away big R to get H.
Yeah.
So we can't put H in.
It's fine. It doesn't matter what we notate it as long as we confuse the most amount of people. I don't really care. Okay, so GSR divided by GH, and that gives us, let's just slap in the numbers, I can't be bothered. GS is that, R is that, and the other gravity is and square root of it, which gives you.
153.
Let's check.
You got
Yep.
Alexander, where's your seat?
Shut.
Where my seat?
I have like 2 days.
And then your shit's all over my desk.
Well, it's not mine. No, this is mine. All my stuff is my pencil case, my calculator, which is the ruler isn't there.
So we're gonna find h. This is r. So h equals, that's r. So r minus h. R.
Really low. That's cool.
Yeah. Okay. And then again, plug in the numbers of this and this.
Hey, we want it to the nearest meter.
Yes.
Okay.
I've used ands anyway, so And what does that give us?
Well,
Cool. Well, it's 6,509.6. So we round that right up to 653,360. Which is the nearest meter.
no, it isn't, but still. I mean, well, 0.5, I guess.
Yeah, it rounds up to the nearest meter. What's the problem?
Should have half a meter in there as well, you know.
Nah, it says nearest meter.
If it wasn't half meters, you know.
The question doesn't ask for half meters, Samuel.
Half meters are nice.
Yeah, but not as nice as full meters. Why say when you're a meter 80 or a meter and a half when you can just be 2 meters?
Oh yeah, that makes you a giant.
Exactly. It's just a better way of doing things.
But what about no?
Oh, yeah.
That won't do much for Leon. He'll just be shorter than he is.
He's like a little friend. Leon is you.
Yeah, I made the mistake of throwing that well, beating it.
Oh, I don't
It
know.
gives a cool sunray though.
There ain't.
Or-
We've got a pre-option, so we just didn't work out.
I realised that I'm kind of doing exam 5 now.
What was the final answer?
It's there. That's why I kind of just wrote it out. Whenever you're ready, everyone. I'll just stare into the sun.
Scroll there.
I gotta turn on the blinds.
Nah, it's fine. Who needs to see?
Oh, look, it's the exact same question.
Except we're finding G.
What if we just don't want to?
And this times Earth.
Well, not perfect, pick up.
So, satellite orbits the Earth of radius 6,400 kilometers. So, big R equals 6.4 times 10 to the 6
Meters.
Yeah, I should
In
probably.
sync.
Oh, yeah.
And the height of.
Above the Earth's surface. So H equals 920 times 10 to the 3.
Yeah.
Calculate the magnitude of acceleration due to gravity at this height. Because we know Gs equals 9.8 meters per second. That's great. So we have two distances, one value. My brain died. Anyway. We also need R because H is useless for the equating bit. So we just add these two together to get H, which is
7,320 kilometers.
times 10 to the 3. Yeah, now we have all we need. We have GSR equals GHR
Square root.
squared, so no square roots in this one. So it's just GSR over R, all squared, those bits squared, equals GH. Sum in numbers, and what do we get? Just make sure that we don't mess this up.
Okay. You don't get to. Or do you?
You get a few times more than 2. GH equals 7.5. Meters per second squared, because we're going to only have the decimal point.
What, 7.5?
Yeah. Fairly easy. And then question 6 is. Oh, that was the long one. Oh. So Then do all that. We have to find the angular speed, find the central force, because that was also the question that I didn't bother reading, or didn't see.
Ah.
We're actually finding the angular speed as well, things through this.
Okay.
So,
mg equals mRw squared.
yeah, mg equals mRw squared, which they both equal f, so just equating them. R omega squared. This is tiny now. So you just rearrange for omega, times cancel, so it's just g over r, square root of that equals omega. Well, we have g at 7.5, r is that, slap them together, which gets you.
That's one to have to remember, isn't it, as well?
One point
Oh god, we should write that up.
1.0 times 10 to the negative 3.
I already got it overall.
Oh yeah, now we have. Are you sure it's? Oh yeah, okay, sure. So now we have to find the periods. I did this completely differently. I just did it in one go and mashed them together, which is nice.
Yeah, I mean, they both work. So.
Yeah. T equals. So basically, omega is velocity and v equals v over t. So through that, this is the same, but 2 pi over the periods equals omega.
6 to
So we just slap that over, so it's 2 pi over omega equals t. And what do we get?
6 to 7 seconds.
6.20
No, 6207. 6,207
Cool.
seconds.
Equals t. I know I make that. And then converting it to hours, just converting to that, which I can't be bothered doing. And it's the wrong one. No, it's not. They're wrong. Oh, yeah, I should probably leave this up.
And we convert it to ergs.
Yeah.
Yes, we convert to ergs.
Well, final one.
103.45 minutes. So that
An hour and
1 hour and 43 minutes.
Made a mistake.
Or should we put it to 45 minutes?
44.
no, we're just
Okay, example 6 now.
what's example 6 then? What's example 6?
Example 6 is a satellite orbiting a primary mass m with a center. Okay, r is the distance between the sat and the primary was r, yeah. And the orbital period of it show that t squared equals 4 pi squared divided by gm multiplied by r cubed. That's a lovely r cubed. I think. So to do this, we equate r omega squared to g m over r cancel nicely. These don't actually. We get r cubed omega squared g m. Yes. So we've got that gn. We've got r cubed. We need 4 pi squared. Oh, what about that last question?
Yeah.
Ooh, 2 pi squared over t, but that's not quite what we need. Was g r cubed. 4 pi squared over t squared r cubed g m. So then we can then rewrite it to like that. So it's t squared. That's now flipped onto the bottom. That's now on top. So we can get 4 pi squared r cubed divided by gm, and then we can just get rid of the r squared and then put it to the Hamilton limited.
Cool.
Yeah,
That was simple.
Not bad.
yeah, that's it.
This one.
That's
And then
done.
these are questions. Now I'm gonna go off to do my leaps.
Like and subscribe.